Great. Good afternoon, everyone, and welcome to today's Aspire Talk. I'm Don Linford, the Innovation Director for Aspire. We're glad to have you with us today. Before we get started, I just wanted to thank all those who participated in our very successful annual meeting. We had over 200 attendees with significant representation from our industry and innovation members, along with great guests and visitors, including the National Science Foundation. We thought it was a very successful event, and we appreciate the support that everyone gave during that time. Before we start, I just want to make a quick call out for an upcoming event in early 2023. I know that we're towards the end of the year. We're starting to think about 2023. There's the biannual industry conference on electric roadways and vehicles. We call that CURV. It's an industry conference that we support. It'll take place February 5th to February 7th in Park City. CURV is a unique single-track conference with panel discussions comprised of experts, program directors, and key leaders in academia, industry, policy, and government. And this year includes overview of the committed pilot projects and coordination between them. So CURV connects the related industries of charging infrastructures, transportation, and electric utilities, automotive OEMs, and fleets. So we'd really, encourage you, if you have a chance, to be part of that industry conference. I'll make sure that you have here in the chat later the link that'll take you to the website and give you more information about it. Just as a reminder, our presentation today is going to run for about 40 minutes. We'll have time for Q&A, and we're recording this session that we plan to post to the Aspire website at a later date. So now it's my pleasure to introduce Aaron Rosenfield. He's Vice President of North America for Driivz Incorporated. Driivz is a leading global software supplier to EV operators and service providers, accelerating the plug-in EV industry's dynamic and continuous transformation. And he'll talk a bit about that, as well as the topic that he's going to share with us today is some behind the scenes of EV charging, lessons learned from the world's largest implementations. Just a few fun facts about Aaron. I had the pleasure to meet him obviously before, and he has over 20 years of business software experience and was one of the first people to help establish the presence of Israeli software companies here in the United States. Before software, he worked in digital hardware devices industry that he helped design chips for high-tech industry, including, for example, Intel. As a personal factoid, Aaron plays jazz guitar and he likes bossa nova. So he and I actually have the same taste in music as bossa nova from Brazil, those who may not know it. So it's a pleasure to have Aaron here. And Aaron, go ahead, it's all yours.
Hey everyone, thank you very much for having me here, Don. Thank you for Aspire. Thank you for the people that joined us. Happy to be here. Sorry about the background. I'm traveling right now, so I'm in New York City, spending this week meeting with the colleagues, partners, etc. And I will share my screen right now so we can start. Don't just confirm that you can see my screen, okay?
Yep, confirmed.
We're good. All right, thank you very much. So today I'm going to talk about again, the EV charging and energy management, the lesson learned that we have from implementation around the world. As Don said, I'm based in Florida, United States, and I'm in charge of leading Driivz in the Americas. And I promise you that I will spend about 3 minutes to tell you who is Driivz, just to put it in the right perspective so you know who we are. And then I will talk about two major areas. One is the EV charging challenges, the ecosystem as we see it, and remind you that today I'm not going to talk about what we think that will happen in the future, but it mostly is based on data that we already have, and you'll see based on the numbers. So this is real cases, real customers, real data that I will bring to you today. The other part will be the energy aspect of things, and how do we see that revolution, and how systems and solutions, either like ours or other, can help to cope with the challenges that we are seeing. So with that, I'll continue and tell you, this is going to be my 3 minutes. Driivz is a company that was established about 11 years ago when we saw those two revolutions that everyone see right now, the mobility revolution, where you see more and more cars and drivers that are looking for cars and so on, and then the energy revolution, where we are not sure that the current energy solutions and grid can cope with the demand as we are seeing it right now, growing and growing. Few facts about us. As I mentioned, we started back then. We are operating system for global EV charging. We are software only, SaaS, meaning on the cloud. We are modular, end-to-end architecture. Some of our customers will pick and choose the modules that are interested of. And in terms of the numbers, we are managing already tens of thousands of plugs, meaning chargers. That's big amounts. That's therefore the data that I'm going to share with you today. Hundreds of thousands on roamed plugs. This is where you can move from one charger to another and use the same app to plug and charge. Hundreds of millions of transactions. Those are the numbers that we see right now. Events of EV charging. We're supporting over 700 different charger types, and we have over 1 million drivers on our platforms, with the presence at I think 27 countries already. Some of the customers that we can talk about that are working with us as their back office software is EVgo, that you might know as the largest DC fast charging network in the United States. Shell, that's starting projects right now with Circle K on gas and oil and convenience stores, and Volvo trucks, and many, many more. The expansion right now that we see introduces a lot of challenges, and those are the main things that we see right now. The number of drivers, and I'm not sure that you are aware of, but McKinsey just published that one out of four American driver announced that the next car will be an EV, an electric vehicle. And we will see more and more drivers. We already crossed the 6+% of new car sales, which are EV only here in the US. Just to compare, Norway is about 80%. Netherlands is about 39%. We are getting there. The data is here. It's very obvious, the numbers. Therefore, the number of chargers will be bigger. If today we have tens of thousands of chargers, or maybe only 10,000 DC chargers, we will see millions of chargers soon, meaning more transactions, more roaming interfaces, expansions to multi-countries, and more, and the energy growing demand, which will be huge. And we will share some slides regarding that part. The last two slides about us, if you see right now announcement like General Motors that are deploying another 500 chargers for their drivers, and working with EVgo as a corporation, that means that they're working on the Drives platform. EVgo is working with us since 2017, meaning operating their chargers, making sure the chargers up and running, helping with billing for the customers, roaming, looking at the energy and customer management, etc. And we have many customers, but I'm not going to spend a lot of time on that. So that's about us. And later on, if you have any question, of course, I'm happy to answer those. Let's dive into what do we see in terms of the EV charging value chain, ecosystem challenges, etc. So one thing that is very, very important, and we recognize it with the customers, is the operations, or how we call it, the operation excellence. Oops, sorry. Okay. I'm having some echo.
Yeah, just remind people to put their phones on mute. I'm trying to mute everyone if possible, except for you, Aaron, of course.
Okay. All right. Now I think it's good. You probably, some of you riding the EV car and heading to a location where you see 4 chargers, 2 of them are up and running, 2 of them are not. This is very frustrating for the drivers, and this is a part that we see that our customers are very concerned of. So that's why the monitoring of the charger, making sure that they're up and running, the ability with AI tools and to assign algorithms to make sure those chargers are up and running. For example, we call it self-healing. So 80% of the problems, we are learning them and then helping to solve them before there is an operating system that need to take care of them. And that's the part that you see here. CPOs are charge point operators, and we see them more and more companies becoming that part. And the other part, what we call the EMP, the e-mobility providers, those are, that's the part that take care of the driver. The call centers, or as a driver, you need to call and make sure that the issue is being resolved, the charger, the billing, the roaming, again, the seamless journey for a driver is very important. So that's one of very important part of the value chain. Probably you heard about the range anxiety and other things. It's all about that. The driver need to feel comfortable, before buying an EV car, that there is places to charge, that there is no problem over there. The other part that we see, it's very interesting, it's the vertical business solution. This part, you can see different locations of charging. So I don't know if everyone is aware about that, but I'll share with you some data, again, based on data. 80% of the charging will happen either at home or at offices, workplaces, 80%. Only about 3 to 5% will happen at gas stations, meaning that the amount of energy that all of a sudden will be added to gas station will be a big one, and it's spread all over, right? And then we will see charging in other places, dealerships, municipalities, of course, multi-dwelling units, the home charges, fleets that are looking for now to build charging depots, and many, many more. Challenges over there, as we will discuss in a second. So those are the areas where drivers will charge, and therefore the driving charging experience will be there. The EV energy management is a huge part, and you can see here that we're going to talk about the chargers themselves, the battery storage that we will see, the renewables, and how it all works together. This is, I don't know why it came here, but this is still part of the software, but we'll skip it very quick. We are out-of-the-box solution, so our customers are installing and then start using. You can see here some screenshots, monitoring the chargers, etc. And we're working a lot on the connectivities and integration to allow customers to work with their applications, their legacy system, other energy-related systems, and so on. So that's that. Why is it complex, and how that complexity look like? And this is this screen that usually when I'm sharing this screen in different conferences, I see a lot of people just taking a quick picture over here, because it's kind of cover the entire ecosystem that we see. So we'll start with the location we touched before. So you can see here the different locations where a customer will charge, and each one of them will need different functionalities. So the home charging, right, which is over here, 80% or close to 80% will charge over there. Just to give you an idea on the home charging, a house in the household in the US is consuming about 3,500 kilowatt hour annually. That's a general consumption energy at the house, 3,500 kilowatt hour. One car is about 6,500 kilowatt hour, meaning that the house with two cars will consume 4 times the energy that they consume today, 4 times. This is why the home charging, okay, will be a challenge. That's not allowed. The infrastructure right now cannot support it with different smart tools. It just cannot. And some of you may know that to upgrade the grid, the transformers, not only that will take a lot of time, I'm talking years, right? For example, a lead time for a transformer today, the quickest one is about 14 months, but it's also very expensive. So we will need to find different solutions for those different verticals, the home, the multi-dwelling units, the workplaces. In the workplaces, you will see solutions like different employees are plugging in and charging. There are several companies working in the same building. How do we allocate the cost of energy? Different solutions are needed over there. Commercial, industrial here, gas and oil stations, that are now installing chargers in order to attract customers. And how do they attract customers? They will need different solutions like loyalty, memberships, coupons, different marketing and ads in order to attract customers to a location and so on. And then the public charging, cities, retail, each one different solutions that are needed over there. On the right side, you see the mobility part. We got the drivers, and the drivers will need a seamless solution. Today, whenever you are run out of gas, you stop at a gas station, fill it in, move on. Tomorrow, it will be, again, different location, and you want to use either an app, RFID cards like today, but I'll give you more than that. Some of the protocols that are being worked on right now, like this one over here, the ISO 15118, it is a protocol for plug and charge. So in the future, your car will be connected to a billing means, etc., and will be able to pay for the charging automatically, meaning plugging it into a charger, everything is recognized automatically, and then the charges will be per car, /driver, etc. This is a technology that we are looking to get in the very near future. The fleets we are seeing right now, and Don just mentioned, the different conferences that Aspire is doing. Some of them are around that. There is a big effort right now around fleet electrification, either transportation or private fleet, etc. And they need different solutions. Over there, you will see fleet depots where different type of vehicle will charge at night at a depot. Buses, school buses, 500,000 school buses here in the US and so on. A lot of energy in one site, right? And also the ability to do some other thing with that. On the left side, the power part. I'll show you in a second how you need to look at the generation areas, the transmission, the electric grid, the microgrids with renewables, and then to cope with that in order to support EV charging. To begin with, the roaming on the left side, the operation of the chargers that we discussed before with the operators and NOC, which is the network operating centers, and the openness and integrations that are needed to different mechanisms, including to the power, the demand response, and so on. This is the ecosystem as we see it, and any solution will have to look at the different players in different areas in order to cope with it in the right way. So what is the energy part and why is it so challenging? I chose here to start, after this one. Look, we have different sites where customers and drivers will charge. And again, I mentioned it will be home, it will be in other places and so on. The sites, as of today, not necessarily can support the amount of energy that is needed to charge cars to begin with, or to charge simultaneously 20 electric vehicles. So what do? We need to look at smart solutions, develop smart solution for that. Also enable to support the V2X. So for whoever is not familiar with the term, vehicle to there is V2G, vehicle to grid, or vehicle to battery, vehicle to vehicle. And how do we use this battery on wheels as energy and local energy generation? We will see more and more. We see it in the US in some areas like California, and we'll see it in other states. The spot pricing or the time of use, the utilities and the generation will have different rates in different hours of the day. And this is something that we need to look, how do we cope with that in order to balance the grid? And the flexibility market in general, that whoever knows how the utilities and the other players working will touch that a little bit, but how can we help to balance the grid and cope with what is needed? And I brought this data slide for you today. And this slide was shared with us by one of our customers, a customer that we started working, I think, over 6 or 7 years ago in the Netherlands. This is a consortium of the DSO, the distributions of energy companies in the Netherlands, which we, by the way, they were one of the ones to start in developing the protocols that are being used today. The OCPP, which is the protocol to connect with a charger, or the OCPI, they are one of the first one to deal with that. So they're pretty advanced in EV charging. As you probably know, the US is a little lagging behind Europe. Few years ago, they didn't think that they will have any challenges on their grid in the Netherlands. And this slide was delivered to us about a month ago, where you can see on the right, the blue area, which is the consumption of energy, the general consumption of energy during the different days. And what happened with the green area, that is the contribution of EV charging per day during some times of the hours. And you can see how it breaking the threshold of the grid. This is where they realized that if they will not find solutions for that, the grid might go out of frequency, and we're talking about blackouts and so on. And we can see that on the left side with a high voltage congestion during the day and some areas that they cannot support the energy that is needed for EV charging, or in the middle here, where there are renewables that being generated, but there is too much energy and cannot be used, again, because there are not enough tools to balance the needs, the prediction, and the commitment for energy. This brings us to the different solutions that we need to see in the market. And today I'm going to share with you some of our approach, but again, it doesn't need to be us. It could be anyone that understand the situation and the challenges in there, and then finding different solutions. So in this case, what you can see here, the way that we do that right now, and again, it doesn't have to be us. On the right side, we know how to create a survey per site, meaning understanding the different, the parameters of energy on a site. And then in this case, you see that it's, a graphic is being made by the software, meaning that you can see here the chargers on that specific site. You can see here the other consumers like buildings and others that are connected over there. And then the renewables on site. We might see solar, we might see wind, and we might see battery storage that I'll discuss a little bit more in a second. So when we do that, so we understand right now the limitation of the grid and the microgrid per site. So we understand how much energy we have right now without upgrading the network, right? So what do we do? What can we do today, right? And then we can assign and build different energy algorithms in order to allow EV charging and still work under the limitation of that area, that grid, and so on. Now, this needs to be done on a charger level, on a parking lot level, or a site, multi-site, campuses, city, and even beyond that. And that's the way to control the amount of energy in order to support, again, vehicle to grid over here, right? Working with battery management and coping with the demand and response that is in the area in order not to exceed the limitation of the grid. You can see here another quick example to the bottom right, how systems, networks of charging need to be connected to battery storage on site. We'll see more and more battery storage that are used in order to compensate or to help with the limitation of that microgrid that is available on a site. Meaning that the battery, for example, could be charged during the night when the cost of energy is lower, when there is more energy that can be used, right? Or charged with renewables and so on. And then the battery can be used during the day when there are peak times. There's not enough energy from the grid to support the EV charging. So you can see here in this sketch over here, and again, this is real data, real screenshots from system, how with the smart energy mechanisms and the right algorithms, the system, the charger knows how much of the energy to take from a battery and how much for the grid at certain times of the day, based on, of course, different parameters. Who is charging? What is the state of charge of the car? How much energy is needed? And many more parameters over there. But more than that, we can also discharge the battery to the grid whenever that technology will be available, because it's not available anywhere in every state right now in the US. So charge it back to the grid in order to support and stabilize the grid. Just a note on that, discharging to the grid, just to give you an idea. When we are talking about network of chargers that are connected right now to thousands of cars, and either charge the cars, discharge cars, etc., or school buses, where you have a parking lot with 300 buses. You're talking about a huge amount of energy, megawatts, huge amount that can really help with the right technology to support and stabilize the grid with the different needs. But you can do it only if you are managing those chargers. If you'll just put a dumb chargers over there, you have no control. Only if you can manage those chargers, you can do that. Think about the home charging. The home charging, as I mentioned before, the consumption will be 4 times than we know it today. So what happens if we'll just put, again, dumb chargers? Any driver will put a charger and then will decide to charge whatever they want during the day and so on, without any control. Well, I tell you that we know almost certainly that the grid cannot handle that. So we need to find different solution how to control those chargers, as you can see on the left side, on the bottom left, where in this microsite or specific site, microgrid, we know, and this is the orange line, the limitation of the grid over there. Then the cost of energy, this is the purple line, during the day, the time of use, the TOU. Then the light blue, which is the other consumers, the general consumption of energy as we know it today during hours of the day. And then the EV chargers and how we can balance them to work within the limitation, cost of energy, and many more. Side note on cost of energy. If you are a retail, you don't pay for energy like a home use right now. Home use, whatever kilowatt you use, you pay for it the same rate and so on. If you're a retail and you are reaching the highest peak, then there is something called demand charge, meaning that they're on top of the usage, they will take the highest peak during the month, the highest 15 minutes, and multiple that by 30. And this is another, call it a penalty if you like. So this is very, very crucial, not only to support and to cope with the limitation, but also to work right with cost of energy that will happen because of EV charging. Here is another example that I brought to you today. And again, real data, real customer. This is a fleet, a depot that cars are connecting during the night or the morning in order to get charged before they go into their routes and so on and so forth. And in this example, you need to understand that we understand and we know the cars, we know the drivers, we know the routes, right? We know when they need the car, and we know what's the state of charging over there, meaning what's the state of battery right now, how much they need, and so on and so forth. Therefore, the integration to different software, different systems, and so on. We also know the energy cost. Therefore, integration with the utilities and the time of use and energy cost. When we know all of that, right, and we have on the side, for example, a battery storage, which I mentioned before, see what happened. 4 cars are plugging in to chargers 7:30 in the morning, but only one of them start charging from different reasons, right? But the charging starts from battery only. Only at 10 a.m. when the energy cost drops, assuming that we know that it's okay and the cars are not in a rush and we have more time, then 4 of them move to be charged from the grid. And then they're ready whenever they're ready and so on. In this real case, real data, in the bottom right, we see a 23% cost saving on the energy. So not only helping the grid, but also reducing the cost of energy. And maybe one of the final slides here to share is the entire value chain of the energy, to summarize that part. At the energy, different players, you will see the energy producers, either green energy or polluted energy, doesn't matter, renewables and classic energy producers. And then you have different parties, like the balancing party. The balancing party is the one that is looking at the demand and actually bidding that part in order to buy energy, the right amount of energy in the right time. So this is something that's happening during the day, and sometimes even 5 minutes before the time slot. This balancing party is bidding and buying the right amount of energy. And again, there are a lot of penalties if the prediction is not right. All right. The TSO, this is the transmission part. The DSO, which is the distribution. The metering points operators, the electricity providers, as you know them, all the way to home. The consumers, different consumers, the EVs, right, and the local energy producers. All of them need to work together, like with the items that I shared before, in order to make sure that the prediction is right, that the generation is being generating right now the right amount of energy. There is not excess energy, there is not lack of energy. All of those need to talk together, especially understanding the EV, big, new, large load that I show and I shared with you before, that is happening. It's not a matter of will it happen, it's a matter of when it happened. And we know that as well, because you can Google right now and see the amount of cars that are being sold and how many drivers, new drivers, and the amount of energy. It's all visible already. So it's what will happen in the next 3 to 6 or 3 to 7 years. We will see it more and more, of course. So the ability to control all of that, the ability to balance the entire thing, that's the key item on the revolution. That's the key solutions that all of us need to look at and solve. And one more item over there, just to again to allow you to understand the power that a network of charger has. The ability for a network of chargers that right now is connected to 4,000 DC fast chargers, and there are thousands of cars right now connected and charging. The ability for those networks to get a pulse and notification from the grid, from the utility, using either ADR, automatic demand response, or any other mechanisms, in order to say, hey, listen, we have a problem right now in a specific area, and we need to lower the consumption. The ability for that network to do that with the smart tools is crucial in order to help the grid. Again, otherwise we'll see blackouts. And the ability to all of a sudden to send pulse to thousands of chargers and lower the consumption over there from 100 kilowatts to 20 kilowatts, or you name it, this will be very important. Same for home charging. Over there, we're talking about millions of chargers. What happens if those millions of chargers are just non-managed and then charging at 2 p.m. or the peak hours, or whatever the peak hours are per state, with no control? This is where you lose the balance of the grid. It might lose frequency, and then we are talking about blackouts. Just to summarize before we go to Q&A, any solution need to look at ability to scale with flexibility in order to cope with the challenges that we saw today on where you charge, what are the verticals over there, what is needed, and so on, the integration that it needed. Without artificial intelligence, the AI, I don't think that we will be able to balance the grid as we mentioned before. Security is an item that you see more and more right now in terms of the chargers and the data from the customers and the sessions and so on. The functionality side, I shared with you the ecosystem and how do we support, the different areas, the home, the work, the fleet, the public, and so on. The seamless driver experience, which we see that is very important right now. I'm talking a lot with car manufacturers that would like to provide their drivers an application where the driver can find a charger easily, reserve a charger, get to a charger and plug and charge, and all the easy parts of charging to make it a seamless experience. The smart energy management that we'll discuss, that is very important in order to cope with the demand and the roaming between one charger to the other. So between two different companies, I don't want to, as a driver, I wouldn't like to hold 10 different applications in my cell phone in order to charge in different ones. So I want to just use one. And then to support with the right implementation and the service level agreement and automation of implementation of those millions of chargers that we are about to see. With that, I'll leave you that our vision is really to recharge the planet. We're looking at this challenge as an opportunity. So one would like to recharge the planet for generation to come, and that by driving the transformation of EV to battery storage on wheels. This is us, and this was me, and I would like to thank you for listening.
Thank you, Aaron, for that very, very interesting presentation. Just reminding everyone that we're recording the session. If you would like to ask a question, please feel free to unmute your audio and turn on your video, or you can also send comments in the chat or questions in the chat. So Aaron, I'll try to look at the chat if you want to or not. I see that Brandon already has his hand up. So Brandon, why don't you start us if you don't mind?
Yeah. Thank you for a good presentation. I really enjoyed it. I just have one question. So I know that you used the value chain at the beginning, and I was wondering, is the value chain only limited to like the business model, or do you all see value beyond the financial aspects of it? So you think about like community impact and equity and access of electric vehicles as part of the value, understanding like what it means for climate change and environmental change. Is that part goes into the value model? Because it seemed like it was only focused on like the business side of things.
So as a software company, what we are focused on and our strategy, of course, is just to develop the right tools to support the different players in this market, if you will. And we see that, for example, for community, you see the effort from municipalities and where do they place chargers, etc. What I see with our customers, that we are supporting them the data, right? So they can see where to place chargers and so on based on real data. But we are really concentrating on the solution and technological wise, and we are allowing the customers that again might be government networks that's supported by government, because as you know, there's a lot of federal NEVI funds and so on, to look at those aspects of the rest of the value for your question.
We have a couple of questions in the chat. Thank you, Brandon. I'll look at it here. One of them is, what a criticism that's surfaced of late by EV drivers is that they're being overcharged, presumably based on the length of time they're connected, rather than the amount of electricity received. Is there anything being done by industry to rectify this, or will it require legislation?
This is a great question. And based on my knowledge right now, working with the different states, I think it's more of legislation than anything else. I saw that there are some places that allow to charge per minute, some places to allow to charge per kilowatt, which makes sense, of course, to charge per the amount of energy. I'm sure that it is a combination of legislation and competition in the market. So as we will see more and more networks in the market right now, I am sure that then this is where you'll see the benefit as a driver.
Thank you. I'll just keep here in the chat. Can you amplify your comments on the impact to the household energy use? Did you say adding one EV would double the kilowatt used?
I love this question. Someone was listening. This is great because I'm talking, you know, with utilities and so on, and I think that some refuse to believe. But yeah, you can look it up, and I think that an average usage of household is about 3,500 kilowatt hour annually, when a car can reach 6,500 kilowatt hourly, meaning yes, it almost doubling the amount of energy, or actually tripling the amount of energy that is needed per house with one car. So adding two cars, it's more than that, of course. So yeah, a lot of energy is needed. And just to give you an idea, I just came back from Puerto Rico last week, working with their utility companies over there and assessing the different things. So you take a street where you have few EV like Teslas over there connected and so on, just few of them, and you have those transformers that can support an X amount of energy, right? And those chargers that are people installed are non-managed, right? So as soon as it will get to the fifth customer, the sixth customer on the street with those chargers, and all simultaneously will charge at one time, that's it. It will pop, and then you need to replace. Yeah.
Very good. And that's based on status quo, right? No change as is today is what you're looking.
Correct. And no smart energy tools, right?
Correct. Very good. We'll go here to the screen. Joey, you have your hand up. Feel free to ask your question.
Yeah, so thank you for this presentation. It was informative in a variety of ways. Right, so I guess kind of jumping off of the last question, right, you talked about how an electric vehicle will effectively double what a house energy kind of requirement is, and also talked about, right, these massive strains that this will put on the grid and the need for millions of chargers that will compensate for these sorts of things as well. Does that not prompt some consideration of infrastructure changes away from cars as the sort of major mode of transportation? If it is that, right, they're going to come with these massive energy draws and issues.
Yeah, I think that I think it's a little beyond what we do right now, but I think that will drive different solutions into the industry. I already saw companies like in Florida, there is a utility company, FPL, that are promoting right now smart charger to home, and like a fixed price for a charger and a fixed price for energy if you will charge at night, for example, meaning they can control when you charge and so on in order to control that. I think that we'll see many changes around that, including, you know, the use of transportation, and they will have to come to a time where there will be a limit, seriously, then other solution will be needed.
Thank you. We have a couple of comments here in the chat I'll look at. One is Talis Blaylock, our managing director, is kind of putting a comment related to one of the previous questions, that when people are charged by time instead of energy, it's normally due to state regulation, stating that only electric utilities can sell energy by the kilowatt hour. States have been changing those regulations, but it'll take time. Just supporting kind of what you said. All right. Just looking at a question here, can you talk about any potential for addressing resiliency through a system of network chargers during grid blackouts, for example?
So I'm guessing is that the question is about how can we use the amount of energy that is available in cars in order to help, right? With in those cases, I think that this is being considered right now. And I actually, before moving and before going to Puerto Rico, I learned a little bit about that because, as you know, Puerto Rico, but they suffered from Maria and they had 74 days with blackout, et cetera, et cetera. You see today, Tesla, for example, home batteries that are being installed in order to support the electricity at home. So you see that, and this is only 50 kilowatt hour batteries. A car has usually 70. So as soon as you'll have the right technology with a car and the right technology at the home network to support it, a car can support a house, right? For I think over 10 days, if not 20 days, for the full electricity needs, including air conditioning, etc. That's one. If you take parking lots with a lot of energy, absolutely. But this is not the highest priority that we see right now. The highest priority right now is about balancing the grid right now and actually make sure that the grid is being safe. This is the top priority right now. Later on, we will see some other applications.
Very good. No other here. So just looking here at on the chat again, are you working with any medium duty or heavy duty truck fleets that are building depots? Their energy demands can be huge compared to normal loads on the grid.
That's correct. And the answer is yes. We are working with a lot of fleets right now. And actually, we are kicking off a project with the largest privately owned fleet in the US. We're talking about tens of thousands of different, different types of vehicle, including trucks. There are many solutions that we see. Some of them are depots that are being built in places where there is a high amount of energy available, but also we see that those depots are combinations that using an energy, the grid energy, but also battery storage that can become now bigger and bigger, and different renewables. So a combination and creating a microgrid in order to support it, adding the management, the right management tools over there will enable them to support the needs. Again, if you have 20 trucks coming and plugging right now and to charge, but some of them have 70% battery life. They don't really need right now to charge. This will be important to understand when, for example, allowing the truck driver with the app to reserve a charger, right? When we know the route and we know that it doesn't really need right now and so on, or how much they need in order to lower the consumption of it. All of those tools will allow to cope with the energy that is needed, which is very, very big.
Very good. The next question is a single question, but wrapped kind of in four. So it says, what customer experience can your existing SW provide? Does the driver tell the app how long it will be at the charger and how much energy it wants? Then you execute this most cost effectively. Do you have options? No delay and expensive versus delay and lower cost, higher power versus lower power?
This is great. This is all features of his software, and for the fourth question, the short answer is yes, 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 yes. But it's all depend on the network. So what is the network that are actually handling and using, for example, our software want to do with the driver? Do they want to promote and incentivize, different prices per different, consumption or amount of energy and so on? Those are all software enabled, and it up to the network to decide which one to utilize.
Okay. And just so you know, your presentation is international. We have a question from the University of Auckland in New Zealand. So question is, was the increase from 3,500 kilowatts to 65 kilowatt hours you talked about for one EV charging a home, is that based upon a BEV coming home almost completely flat? So energy snacking with dynamic charging during the day in future will help balance this demand to shift supply to areas that can cope with the demand. Is my summary correct?
I want to say I think so. Since I don't have my calculator with me right now, I'm happy even to take it offline and do the math over there. But I think that, and good morning, Oakland. But I think that the summary is correct.
Very good. Any other questions from those who are on video? I kind of had one, just waiting for another, related to data. You showed a lot of data, but one of the things that we're looking at is how do we gather data to really measure what's taking place and being plugged in. You have your customer experience, but what is your thought around data analysis, data gathering, and how do you guys look at that?
So I can share with you that since we have, again, a lot of experience and hundreds of millions of transactions, right? So we gather a lot of data, and what we do, we don't own the data. Our customers own the data, and they can use, of course, their data in order to make decisions, or where to place a charger, and how much to charge and when, and so on. We use the data mainly for an AI in order to improve the different tools that we have in the system. So, for example, the stability of the charger, to understand what failures are common to what type of charger, and how do you build different mechanisms to solve those items before any technician need to run and fix a problem. That's data that we will use in order to improve the driver experience. As long as other areas where we can see, what type of cars charging, and what's the amount that is being charged at home at different verticals and different locations, what hours of the day, in order to help with the prediction and so on. So all of that data, either we are improving the tools in the system, or are being used by our customers for whatever their business models are, with the utilities, with the energy pricing, and so on.
Very good. Looking at probably one of our last questions here from the chat is your company doing any lobbying of policymakers for particular policy solutions?
Thanks for the question. Personally, us as a software company, we're not lobbying with the policymakers. I assume that some of our customers that are big customers and public companies are dealing with government and policies and so on, but I cannot expand on that since it's their, of course, data.
Very good. Any other questions? Last call. If not, thanks for joining, and thanks to Aaron for what a great presentation. Very informative. I think it's like a musical concert. It creates an appetite to come back for more and understand more. Just to remind everyone, today's presentation will be eventually available on the Aspire website with the member logo login. Our next Tech Talk is going to be on December 21st. And just a reminder about the Curve conference in February. I put the site out into the chat. So if you're interested, please take a look at that. And one of the things, Aaron, we're being asked is if there's an ability to share some of your slides with people who are on the call today, if that's possible or not.
Since those slides, I saw it already in some presentation that we gave around YouTube. So I guess that's okay.
All right, so we'll follow up with that. So with that, thank you everyone for joining us today, and we'll look forward to seeing you at our next Tech Talk. Thank you.